Today I will share an integrated approach to cutting blast furnace fuel cost, which is one of the most burning topic in today's world of blast furnace. As we know that fuel cost is the main cost which which is directly related to cost of production and profitability. So this is very burning topic. Now coming to the agenda about which topic we are going to discuss which are contributing in lowering blast furnace costs can be like material and fuel management. It is also about a very burning topic or important parameter, that is about a smelting and technical control. It is also about the furnace lining maintenance, and this is not only enough, the advanced strategy for cost reduction are also the means which is going to play a tremendous role in curtailing fuel rate of blast furnace. So now we are coming to the next step about our background and objective. In today's competitive steel market, reducing fuel usage is crucial for profitability. As I have already mentioned, our goal is to lower the blast furnace fuel rate, optimize energy consumption, and support sustainable operation. I think it cover each and every aspects of modern steel making. We all focus on these three pillars. What are they? These are the material and the fuel quality control, optimize smelting processes, and proactive lining upkeep. So we can say that almost everything is being covered in this. Now coming to the material and fuel quality management, we can see that burden structure, which is supposed to be a core activity, balancing cost and performance in the burden mix is a key that cannot be overruled by any one of us. We consider the sinter output, the pallet availability, and the lump ore quality alongside fuel consumption metrics. That is, for a typical 4350 meter cube furnace, an optimal mix is around 76% sinter, 19% pallet, and 5% lump. This is the texture or the matrix of the burden is typically architect for a typical 4350 meter cube furnace. Yeah, to meet both production and cost target. It is balanced in such a way that it could meet the production and that would also suit its cost targets. So now coming to the next slide, which is about the material quality control. So consistent feed quality ensure a stable operation is the universal truth for any blast furnace. Automatic center sampling every 2 hours with chemistry and strength data logged in our process system. Manual checks for pellets and lumpur on density, reduction indices, and compressive strength. In blast sampling from sharp mid layer to monitor reduction progress and particle size shift. Everything needs to be recorded shift wise. So now coming to the slide which is basically about the same thing which we have just refreshed, Sinter, the auto sampling every 2 hours, upload chemistry and strength to ERP. Similarly, palette and lampor sampling, that DTR and RDA and compressive strength is to be logged, and this all materials quality control is to met in a consistent and religious manner. So as you can see also this is also a database which is exemplifying what is being talked about in the slide. Now, as we know that coke and PCI management is one of the very important, and we can say it is a key aspects in optimizing fuel rate in blast furnace. So fuel management revolves around coke standards and PCI precision also, because unless until PCI has got a lot of hunting, not consistency, discharge unevenly, unsymmetric, it's not going to pay us. We need to concentrate around the parameters which helps in mitigating the PCI precision. That is very important. So regular coke sampling, we can say that the coke standard and PCI precision, regular coke sampling measure as contain a strength and size distribution with immediate review. PCI coal is specified for volatile content of, as it is mentioned, it is around 17 to 21% and calorific value around 30,000 kilojoule per kg. The target PCI injection rates of 195 to 205 kg per ton hot metal for optimal fuel economy. As this is a one of the very important graph which is showing that increasing PCI raises blast temperature and reduces moisture, enhancing gas utilization. The fuel rate bottom out on around 180 to 190 kg per ton hot metal of PCI, with the most cost effective band at 195 to 205. Beyond this range, a lower fixed carbon and extra auxiliary power begin to push the cost up. This is about a smelting intensity and gas flow control. We use an integrative smelting intensity metric, that is coke plus zero point 0.9 into nut coke plus zero point 0.8 into PCI to the to target 1.05 to 1.17 ton per meter cube per day. This range minimizes the fuel use and maximizes the throughput. So Bosch gas flow is controlled below 10,600 meter cube per minute with a unit area index around 2.3 to 2.4 for consistent blast distribution. So now coming to the prolonged campaign, which we know that this requires strategic refractory repair, and we can say that hard pressing in 200 to 750 kg of castable per drill hole to restore shell thickness. A wet process granite layer of 150 to 250 mm to seal spalls swiftly. Grouting hearth gap to prevent blow by, preserve integrity and avoid hot spot. So these are the basically keys. So now coming to the advanced cost reduction strategy. In order to mitigate this strategy to push efficiency further, uh, charging a smaller sinter fraction that which are lesser than 30 mm alongside pallet to boost permeability and limitage channeling is also a key. Short coke by size 25 to 50 mm versus more than 50 mm to stabilize the stack interior is helping a lot. Introduce MgO enhanced pallet around 2.5 to 3% MgO to delay shafting and sharpen the cohesive zone, reducing slag volume is also paying back a lot of fruitful dividend. Now coming to the key takeaway and the next step, summing our approach, we can say that optimize body mix and PCI range coordinate, gas flow and oxygen enrichment, tightly scheduled timely refractory maintenance,